Uh, Welcome to day 2 of 525 CAD-a-thon. Today, we're going to be continuing on with what we were working on yesterday, which is constraining this intake plate, and we're going to start implementing some uh, off-the-shelf parts and be putting all of this into an assembly. So, the learning objectives for today are fully constraining sketches within OnShape, being able to use off-the-shelf parts while CADing, making gear trains, and calculating torque or velocity in a given gear train. So, some purposes for a ratio is that direct driving shafts with like a motor directly on the shaft that we're wanting to spin. That can damage the motors. Say we have like a motor and then we like stack a bunch of versaplanetaries so that we can get to a torque. That will then damage the versaplanetaries, stripping them out. It's just not a reliable way to drive with either higher torque or higher speed. And so using ratios with these spur gears allows for more flexibility. We can have it further away from the shaft we're rotating as well. And we're able to do this with either gear ratios, so like a chain of different gears, belts, so that would be with your little pulleys, or chains where you'd have two sprockets and a chain going around them. And then there's other simple machines we can use to manipulate these objects. Just some stuff with your gear ratios. So this describes it in terms of velocity. So the A gear here, that's your driver. So that's where we'd have the motor driving. So our motor would be directly connected to the driver. In this case, that has 42 teeth. So from the velocity from the driver to the B gear, we can see on the right that's calculated with the number of teeth of that idler gear, the 28 over 42, and that gives us the velocity. And for the torque, that's just going to be the inverse. So instead, it would be multiplied by 42 over 28. And then from B to C, we have 14 over 28, and that'd be the reverse. And we can see with the overall velocity ratio that when we have a chain like this of multiple gears, the stuff in the middle, it cancels out with this fraction, so that 28 on the left and the 28 on the right, when we do the multiplication, they'll cancel out to 1, and we'll have 14 over 42, which simplifies down to 1/3. I touched on this yesterday for why our intake has 4 gears. So that's so our intake wheels spin in opposite directions to kind of suck the note up. So for our intakes that will have like 2 or 4 rollers, we'll be using an even number of gears to drive this, while odd number of gears would cause it to spin in the same direction. Ryan, would you like to start talking about some chains and belts for us?
Sure. Have you been using arrow keys to move between the
Yeah,
sides?
that's what I've been using.
Okay. So chains and belts are similar in a couple different ways, and they have some key differences that can cause issues. So pros of chains and belts are that they aren't directly connected to each other, which means they aren't necessarily wearing as badly, and they aren't causing as much backlash depending on how you use them. They're lighter because you don't have to create an entire gear train along how the distance that you need them at, and they're more configurable because you can essentially swap them, and it doesn't directly affect the tensioning systems that you'd usually put on these. Allow you to switch out the number of teeth and general positioning things without having to recalculate the entire thing. The cons are that sometimes there's extra complexity with them, and they have some added constraints. So the cons is that both belts and chains have to be correctly tensioned for them to work, and some of them, specifically belts, can stretch, causing some repeated tensioning things. And then belts come in specific set sizes, or at least belts with teeth on them. So you have to find a way to make sure that the end and they're the two endpoints match with the length of the belt so that they're tensioned correctly. And then chains, it's a matter of choosing which chain type is a good idea. Number 25 is smaller, which we use for our hangers, and number 35 is bigger. And that's what I've seen used most commonly for manipulating large pivot arm joints. And those chains have to be made to as close as you can possibly get to the length of the 2 points you're connecting. So the function of ratios here is that they essentially all work the same way. You have the start and the end gear, and you have them, the difference between the two leads to a difference in torque, a difference in speed, and allows for some fun manipulation that would allow us to increase the torque on a joint that has a lot of forces on it, or increase the speed on something that needs to move really fast, and just overall reduce the impact of something breaking. Let's see. And torque and RPM are technically governed by the maximums are governed by the motor you've attached it to, but overall it's offers a lot of flexibility. Other simple machines that I'll just touch on quickly are levers, screws, and wheel and axle systems. And levers, I think the most applicable representation is pivot joints on an arm system. So if you're trying to understand how much torque you need to use in your gearbox to put on the arm joint to make it move up and down without breaking, you would use one of the lever systems and understand how much force is on the pivot point. Screws are useful for high torque environments and precision movement because a fun, interesting note. There is a 24-to-1 ratio, and it's almost always a 24-to-1 ratio for screw. Actually, I might be wrong about that, but typically closer to 24-to-1 on rotations of a screw to distance traveled, meaning you can get higher precision and much higher torque at the expense of less distance. And then wheel and axle, it's a wheel on an axle. You get less force imparted on an object the larger the wheel is, and you get higher speed on the outside of the thing. So that's why a lot of the shooter mechanisms that we saw were larger wheels because it allowed higher velocity. Moment is essentially the special word for the force around a pivot joint or point, and it multiplies with distance. So if you put something heavy on the end of a long arm, it leads to some issues. So a 10-pound manipulator on a 4-foot arm is noted on the document equals to 40 pounds on the pivot point, which would have to be counteracted by whatever chain or sprocket system you attach to it. Or in the case of 2023's robot for our team, 2 1,000-to-1 gear ratios. It was a decision-making time. Torque is similar. It's a twisting force on a rotational joint or shaft, and torque and speed are proportional in most of the gear ratio and ratio systems. So if you have a higher torque, you get a lower output speed. If you have a higher speed, you get a lower output torque. And even if the math works correctly with the input and output side, there's the importance of if the torque you put on the part exceeds what the part breaks at. Like if you try to put a whole bunch of force through a gear ratio or a planetary or something with smaller teeth than it probably should have, you're going to end up breaking the gear before you actuate the arm correctly. And then these are the calculators and resources that we can take a look at while we, I'm assuming, go through feature scripts and actually start importing chains, belts, and gears into your part studios and making some of these things more cohesive in a document. So Recalc has more than a chain calculator, but that's the one I found, and that's the one Keegan pointed out. And that essentially covers a whole bunch of different systems. What WCP gear calculator is a gear calculator, and then frcdesign.org is a organizational website with a whole bunch of things. It's examples of mechanisms that have worked in the past, and it's just general. It has some helpful feature scripts on it too, and I think we will also be covering more feature scripts as well in the rest of this document. Yes, I am right.
So before we get into fully constructing that document, we're going to need to mount a motor to this plate. And something that just makes it quick and easy is something called a feature script. So we can begin by just importing one at first. But if we go to this link, the OnShape4FRC.com, I showed this website a little bit at the end of yesterday's meeting, but if we go to the CAD library here, first it gives us this MK CAD like breakdown on what it is, and we will be using that. But first we're going to be installing what are called feature scripts. So the first one we want to grab, we're going to be grabbing multiple of these at some point, but we can start with just one. So it's this motor mount hole generator, and we're going to use this to quickly add the motor mount to our part studio.
Before you go ahead and do that, get this up. How did you get there? You just clicked on it.
Yeah, so the website is OnShape 4, as in the number, FRC.com. And then at the top, there's a tab for CAD library, and I scrolled down until I found the motor mount hole generator. All right, is everyone here?
I did not. So you went to OnShape. Just scroll on down.
Yeah, or you can use Control F to look for motor mount hole generator.
Thank you.
Yep. And what we can do from here, we can hit copy link, and then we're going to go back to our OnShape document. And if you're in the sketch, we'll click out of it. And in the far right, next to the search tools, you guys should be seeing a little plus sign where mine is saying tube converter. So if we click on this, we'll see add custom features. We can click on this, and it says search or paste URL. So that's where that copied link will come in handy. We'll just paste that in, hit enter, and it'll give us Julia's feature scripts. Julia's a student on Mechanical Advantage, and she published all of these for use by other FRC students. So for now, we can just copy the feature scripts that are useful from her document. So what I found the most useful to be is this chain path. So we can click on the chain generator. Under fillet expert, we have fillet all edges, which will round all the edges at once. The main one we're going to be using right now is this motor mounting one. So we'll click on that to add it. There's a shaft generator, a spacer generator, and then a tube converter. Does everyone understand how to get to this point?
Did you go in the list of what you're pulling again?
Yep, I'm pulling the chain generator under chain path, the fillet all edges under fillet expert, motor mounting under motor mounting, shaft generator under shaft, spacer under the space, tube converter under tube converter, and that's it from this document. All right. Just give me a thumbs up once we get to this point. Does anyone need help, or is it just time right now? I think it's just time right now.
And then I believe that probably means you select the board. I don't know. I like it because it means you can toggle on and off whether you got created a document in a document. Which essentially means if you don't want your frame to still be
All right. Are we ready to move on? Okay. So, getting into this sketch now. I misled you all. This 45, we're gonna change that to be 135. So that'll just flip it. So instead of going diagonal this way, it'll go diagonal the other way. And that moves some things around. If you want to, you can move these circles back until it looks prettier to you. I don't know why it did that, but we're gonna do that. So we're just changing this 45 that we had yesterday on this line right here. We're changing that to 135 so that we can flip it so that it's going diagonal in the opposite direction.
You had to do that so that you could put the screws in.
Mhm.
Whatever it was interfering with there.
And then, do you guys have this? Just where this line is flipped. It doesn't matter if your circles for these gears are in the exact right place. We'll get that sorted out. All right. So next, I want all of you. So this dotted circle, click on that, and we're going to change this into a construction circle so that our feature script will properly generate onto the document. So we can do that by hitting the construction tool up here, or you can hit Q while you have it selected. So now both of these are construction lines. This inner one describes the diametral pitch of our 20-tooth gear, and this outer one describes where our bearing hole is going to be. Next, we're going to use a corner rectangle, and I'm just going to put it over here. And I'm also going to make it a construction, so while I am in this tool, I can hit Q to make it construction. And then while I'm able to edit this top line, I got these from the VersaPlanetary product page. I looked at the drawing to get these dimensions. This square is going to describe the space our VersaPlanetary is taking up. So this top line is going to be 1.654, and our second one is going to be 1.75. So next, I'm going to move this rectangle horizontally by grabbing one of the vertical lines and just pushing it to the side here. I'm going to grab the dimension tool, and I'm going to dimension it to the side of the plate so that it's not going to interfere with our Mark IV-I or anything like that. and we're going to set the distance between this and the versaplanetary and the edge of our wall to be 3/8 of an inch, or 0.375. And so that locks our square horizontally. So next, we're going to be using the point tool to add midpoints to the side and top of this. So we're going to select our point tool by either clicking it or hitting Shift S. We're going to go to this top one, or you can go to the side one first, and we're going to hover over the line until we see that little midpoint box pop up with the line and the little dot in the center, and we'll see a square around the point we're selecting. So then if we select it, this point is locked in on the center of our square or rectangle, and we can do the same for the side. Is everyone good getting to here? I didn't hear anyone say no, so we're going to push forward. We're going to use the horizontal tool. We're going to select the center of this circle that is going to be directly driven by this versaplanetary. And then we're going to select the side wall, the midpoint that we added. And so that moved our box vertically to that point. And then we're going to use...
What is the horizontal tool?
It...
You can select the horizontal tool.
Yep, I hit the key for it. I'm sorry. The horizontal tool is up here. It might be in a drop down for you all. It's this just horizontal line, and like the description says, it's not pulling up, but it'll constrain two things to be horizontal to each other, or if we hit a line, it'll have that line be perfectly horizontal. And then after we do that, I'm going to hit the tool right next to it, the vertical.
What's the key shortcut for that horizontal tool?
H. And for vertical, the key shortcut is V. So once we have that, we'll hit the top midpoint of the versaplanetary and the center point of this. And now we have a fully defined sketch. Except we forgot one thing. And by we, I mean me. Right now, this sketch doesn't show us the size of the screw holes, or the holes where the screws are going to go through to mount the versaplanetary. But we do have this line with that, so we're going to add two construction circles. For this first one, we can just click off and then add the dimension to be 0.196. That's standard sizing for an 832 fastener. And then we can create another construction circle at this point. And what we can do is we can use the equal tool by either hitting E on our keyboard, going up here, and hitting the equal sign. And we'll hit our first circle and our second. And then I'll have the two be the same. I'm going to confirm this sketch quick and then go back to it. Does anyone need help? Okay, Ryan. Let's work this way for the people who need help.
Okay, which one?
You have John first.
Okay. You okay?
Okay, so
Okay, I can put it
then
where
you
you
use
horizontal
right now, only right after.
So you line the center of the circle with the midpoint.
That one is 1.65.
What if you say you just put it horizontal?
Yeah, I don't know, that's the question.
The midpoints.
To the midpoint.
So that
Okay.
what doing the horizontal and vertical of those 2 points does is it exactly centers that circle on inside the rectangle. Another way we could have done this is by having two construction lines go diagonal from the 2 points, and then constrain it so that our circle, the center of the circle, coincides with both points of the line. It's just two different ways to do the same thing. do you know how to connect to the internet for the?
It's there, or you can just use.
Okay, so you're gonna need to dimension tools.
For example, the bridge.
Is he selected?
It should drop it.
1.75 for this dimension.
And then I'm wondering why the holes are in this.
Okay, so that's with our horizontal and vertical.
Yeah, vertical.
Oh, so did you already hit horizontal?
Not entirely. I don't know why those holes were what they were supposed to, but I'm
We're
going
gonna have center point.
Boom.
Oh my god, that's
So then we need to add the
I see where they're
circles
supposed
for
to.
attention.
So if you want to grab the
0.196.
and it's the very top.
Command
the
C,
center that
Control
goes
C that.
grab it.
So-
Find it. Point that way.
So you now want to mark the line up. So right now, because we didn't move it on the inside, it's dimension about to be on the outside. So delete that dimension right now. Grab the and slide it in. Yep, that's
So I think what you take that horizontal to this,
Okay, so basically.
this horizontal to
I'm
the
working
center
around
of
the
that
table.
circle. And then this vertical circle.
And then we're gonna
Actually,
make
let's
this.
just go inside.
Now,
That, make grab the center point there.
Yep, when you see that north direction, and that possible line, you know you're on it.
And then
We'll do
if
the
you
same
have the
for
whole
the
circle. Are y'all okay?
And then
What did he do with this?
we'll do the horizontal and vertical. Do you know how to do that?
I don't know.
So you just
Oh,
horizontal on that.
Yeah, that's a weird.
So I don't know how to do vertical. Because we want the center to be straight up and down.
Okay, so this is OnShape as an interpretive language. You are fully constrained, but you are fully constrained in the wrong way. Cool. So
Did we
you're
put
going
in
to have to
a wrong
break one of
dimension?
the one of the tangents on this circle. Preferably the center.
Yes,
Break it. Press on it. Press backspace. You move the circle up to the other side of this,
So, yeah.
and then tangent it again.
Okay, that's.
And then you grab this. Grab the construction
Try
circle
again.
here.
With
And then the circle there. Okay.
that.
It's OnShape as an interpretive language.
Let's see what it's saying is wrong.
Everyone okay over here? Oh, you have the same issue.
I do, but I'm not sorry. This line that forms
It's something
Delete that.
which should be coinciding with.
I think it should just be coincident to the center point and diagonal. But I'm wondering why it's the length.
What is that word?
The length shouldn't matter.
I'm not just. So let's go. I'm not sure about that one. I'm not seeing it. Did you grab the part?
I'll control Z along.
I was too busy.
We're gonna delete this. We're gonna start with yeah, that's the actual while we were
Well, I did also I did have that on the breaker. And so the wire is around under and out to the breaker. The breaker.
Oh wait,
yes.
I'm good. Everyone has issues, I understand.
so what's the bigger instruction? So one's not construction, the other's not.
So if we hit extrude on this plate, if we hit extrude
Persuasion.
this point, our
Are the bushes cut down on forests on the barrens? I feel like if that's a fringe issue, you can just drill it out.
Which is fine. And then you can use the vertical and also like what it creation on it.
Right.
Yep.
Anyway,
Okay, cool. Do you have an issue?
At first, it's because the way the square was made.
Is that circle your own personal choice, or is that-
All right. Oh, Sam. Construction line what?
The construction line that's marked the angle.
Yes,
What is it coincident with?
the origin, and then it has a horizontal parameter.
Yeah, the one in the on
This one?
the
The midpoint of that line coincides with the center of these circles.
I think I have it coincident with too much, and it's not liking me.
Huh. Kyle, are you able to help Sam with his problem?
I'm figuring it out.
All right. Are we ready to move on to the next thing? The majority of us. Okay. So, since we have this fully constrained sketch, we can hit the check mark in the top left, and that will confirm it. Our extrude 2 is now mad at us because we're missing the circle because we made it construction. So we can just delete that, and we're not going to lose anything too important. So when we confirm, yep. So I'll Control Z. When we hit confirm, on the side here, we can see extrude 1's fine, but it shows a little caution sign on extrude 2. If we hover over it, it says missing one selection. That's because when this extrude 2 is made, that's for the non-motor intake, where we're going to have these two holes filled in. And so originally, this construction circle wasn't a construction circle, so we had to select it in order to fill it in. And so now we can go back into our extrude 2 by double-clicking on it, and we see face of sketch 1, face of sketch 1, and missing face of sketch 1. And we can just hit the X to delete this missing face of sketch 1, and that'll fix all our problems. I'm going to unhide this intake plate motor. Does everyone have error-free extrusions now?
Can you open the sketch one more time so I can see what's supposed to be happening? Okay, inside square should be
Yes, Sam.
The holes in the corners of the motor mount there. How do you
0.196.
zoom out? What do they?
The center of them is on the ends of this line.
How long should that line go?
I think I have the wrong thing in here. 1.949 should be fine. We'll see if it isn't. And we'll solve it together.
The length of that line.
Yeah, 1.949. All right. Now to use the feature scripts that we added, we can go down here. We'll start with motor mounting. So we'll hit this. So everyone, when we hit confirm on our sketch, can all of you see the sketch still? Or did it hide for some of you? If it's hidden for some of you, we can hover over this sketch 1 and make it so it's visible. So when we hover over it, this eye is going to be open. This allows us to interact with the sketch elements while we're using this tool. So for the origin of this motor mounting feature script, we're going to hit the center of this circle here. Darn. We're going to hit the center of that circle. It'll be red at first. For the hole sizing, we're going to use a versaplanetary because that's what we're mounting. We're going to hit the check mark on this over.
You said we're going to use the versus planetary. Is that pull down someplace?
Yep, so under the origin, there's hole sizing, and
pull down menu. Thank you.
yep, and then it's versaplanetary. Then by default, this override boss size is set to be false. So we're going to click that to make it true, and it'll automatically put in the diameter of a bearing because that's what most people are going to override it for. So for number of holes, the versaplanetary we're using only has 2 holes, so that's what we're going to do. The clock angle, we're going to do 45, and it might be wrong at first. For the angle reference, this is like how when we did the 135-degree angle, we had to click the line and then something else. So our angle reference, I'm just going to click this bottom line, this line that we know is going to be horizontal. For the merge scope, for our 2 parts, it's going to be the intake plate motor. And then it won't automatically generate because we're going to have to flip the extrude. And once we flip the extrude, if we hide this non-motor intake, what we can see,
I don't see the non-motor intake. How do you get to that?
So on the left here,
Now under merge scope.
so past our feature script, I'll walk around this way. Yep. We have our list of parts within this part studio, and for our merge scope, while we have this selected, we'll select intake plate motor, and all I did was just hide this non-motor intake so that we can clearly see the hole it's getting rid of. So while we're viewing it right now, we can see that this smaller circle, which was our 22th gear, that's visible and within our hole, so we know that the hole it's taking out for this center is probably the right size, that 1.125. It's adding these mounting holes. I'm noticing it's not centered, or the center of this is not the center of that. So that means something in our sketch is off, but we can fix that. So I'm going to hit the check to confirm this. And then I'm going to hit top. And to fix this problem, what we can do is click on this circle, the one we added with the motor mount generator, and we can hit the other circle we added with the motor mount generator, and it gives us the center distance down here in the bottom right. It says center distance. We can hit this little tape measure, and it'll give us all the details. So we can see the center distance is 2 inches, and that's broken up by these segments in the X and Y direction. The max distance and the min distance, but all we care about right now is the center distance, 2 inches. So I'm going to hit X to exit out of this dimension, and we're going to update the sketch to be correct. So instead of 1.949, we're going to do 2 inches. And so that'll move both of them across equally. We hit check on the sketch to confirm it, and we can see we no longer have that weird overlap. It's just that this hole right here is larger than this by 0.125. Suhaib. Okay, so if something else is popping up when you hit the tape measure, chances are we selected the wrong things. So when we're selecting, we want to make sure that we're grabbing this circle here on the physical part and not the sketch. So we'll select this circle, and then we'll do the same here. We can zoom in to make sure we're grabbing this circle, and then we'll see center distances too. Before we grab these 2 circles, we will also want to click. Oh, hello? I thought I heard someone talking on the meet.
I have an error in my motor mount. It was red. It says that it did not generate.
I know why it did that, because it took me a bit to figure it out. So with this motor mount generator, by default, it'll have the extrude facing into the bottom here. So the way it's set up is it's going to extrude into negative Z. And we have the sketch going into positive Z. So we're going to have to flip the extrude button. That's right next to our merge scope. It's these two little arrows. We'll just click on that and it swaps it so that this extrude is removing from the bottom here, going up into positive Z. As in the top right, we can see these axes, and it's going positive Z into our plate.
Okay, let's go. What's the angle reference?
For the angle reference, I selected the bottom point here, or this bottom, not the, you can select that and you'll get the same result, but I specifically selected the edge of the sketch here, because I know this line has the horizontal parameter.
Besides the fact that my holes are on the
Suhaib,
It just won't let me take this.
what do you mean it won't let you change the distance? Oh, you don't edit it from the tape measure? I would go up just because that could be a common misconception.
I don't know why we did the full constraint down here.
Wait.
What? You select.
So, when we're getting the center distance between these 2 points, we select our 2 circles, right? And we go down to measure details and we see this. So, it would be nice if we could just click on the center distance here and type in a number. We can't do that. The reason it highlights out like that is so you can copy it if you wanted that dimension to be used for something else. So, what we have to do instead is we're going into sketch 1, and we know that the center distance is defined by the dimension of this line right here. And before, we had it as 1.949, and so we just changed that dimension to be 2 inches by double-clicking the dimension that says 1.949. So that would look like, if we had this dimension right here, we would double-click on it. So left-click twice. It'll highlight out like this, and you're able to type in 2. And then I'll hit confirm to save these changes to our sketch. And now we have that.
Can I have some assistance?
Yes, I'll give some assistance.
So I'm still, my problem is still a little bit
Yeah. Well, okay, so what we did in the sketch was these construction circles out. And then the motor mount section.
Because it's trying to capture that, but it's saying you already did it, and so it doesn't work. Those are just there so we can fully understand it now. Oh, your group are all
Everyone understand what's going on? Anyone need help? Okay. This corner. No.
Go.
All in good fun.
So our.
Okay, I'm wondering. I don't exactly understand. I wasn't paying attention as much. Also, what are the 2 extrudes supposed to be doing?
now it's fixed.
I found most of them. Okay, if it does, if none of y'all know what it is, just delete the second extrude.
So
Yeah, it's 1 plate. It does all the same things. Everyone.
Oh, okay.
Yeah, it filled in holes that you've already cut out, which doesn't make sense to me. I don't know why it's there.
Can I help you from up here, Britton? It's just a general question. Okay, so first are all of the aspects for this motor mount construction lines in your sketch. Are they all dotted lines if we go into the sketch? All of this. This, this, and this are all of these construction lines. Because that would be the first error, is because the motor mount is looking for space that hasn't been cut out of yet. We want to make these construction lines. Do we have any questions? Nope.
He's trying to change that. Oh, you've got 2 dimensions of the same thing.
Same thing, same one.
But they're both
Oh,
grayed out.
Oh, you don't have a third? Does that, you might have a third in that case. I guess delete both of the drivens and see if it turns blue. Yeah, delete both of the light gray ones and see if.
All right.
So,
Um,
still have
are you
a-
4 ready to go?
What's the diameter?
I don't know what it is, but.
0.196.
Well, I can't adjust it. I mean.
In the motor mount feature script, it'll take these to 1.7. The 0.196 is going to show the drilling out we're going to do on our drill press to adequately fit these.
Do what you just did again, but then when it gives you red, ask you what.
Yes. Oh, wait, no. It might be that. Just select it, find where it is. Here goes in. I don't know. And now you can read it.
Are y'all following along?
I didn't see any comments on the group for me.
Fair enough.
And then take some more. You don't get the entirety of
So for presenter view. What do you mean?
So that's what I told you.
Oh. Yeah, I mean, you can do it.
Okay,
Let's do it again.
all 3 of you, or do you also
No, okay. No,
Not everyone.
take a transform and move it.
No, it's okay. There's an
overlap. Okay.
there's an
Can we check on Meet to see if they're doing well?
yeah. How are y'all doing? Wildcard.
Good, really good.
All right.
Thank you.
For those of you who deleted this extrude 2, that's going to the extrude 2 was making our non-motor intake plate. So this plate lacks this hole here for the versaplanetary, and it lacks this one, which is just has a small hex shaft that has a gear. So I'm going to delete extrude 2, so I'm in the same place as you. Most of you have motor mounting. So what we can do is we're going to grab this gray rollback bar and we're going to put it above motor mounting. So now, timeline-wise, if we show the intake plate, it goes to before the motor mounting feature was added. I'm going to hide this part by going down here in the parts list and clicking on the eye. So now we can just see the sketch like as if we didn't have any parts in the studio. So then I'm going to use the extrude tool by hitting either Shift E or the button in the top left. Solid and new for the selections. For the faces and sketch regions to extrude, I'm just going to click on sketch 1 here on the side here under features. And then what I'll do is I'm going to select this circle that I want to be filled in. For the depth of this, we're going to change it to 0.125, which is 1/8 of an inch. And so, if we hit check mark to confirm this, we can roll back the bar and see the motor mounting. It didn't delete the extrude too. When I did it before. Now we only have 2 parts. Oh, I deleted both. Okay, so all of you should have sketch 1, extrude 2, motor mounting in this order, intake plate motor, and a part 2. I'm going to rename this to non-motor intake plate. This part 2 is what it was called for me, the part that we added by making this extrude 2. I'm just going to rename it, just giving it a descriptive name. I spelled motor wrong. You guys should spell it right. And I'm also going to click into it, right-clicking. I'm going to hit Edit Appearance. I'm going to hit this second gray option so that it, looks like metal. And for tessellation quality, I'll make it coarse. I'll hit check to confirm these changes. And now we have 2 intake plates. If I go and unhide this, we can see they're overlapping each other. It looks like I selected 2 different gray colors, and that's why it's like that. So what's the gray color on this one? I don't know why it's showing all these different shapes, but we have our 2 different intake plates. This one with the holes cut out in it, and the second one with only the 2 for the shaft. What was that? Hello?
How did you associate a feature to a certain part in the part studio?
What are you referring to in specific?
Let's say you wanted to go and add a feature and you either wanted it on both of them or you wanted it on just you control that.
I actually have an example for how to do this with our next thing.
Okay.
So, do we all have the fillet all edges feature script? I'm going to grab that. And for the face, I'm just going to hit extrude 1. I'll hit the face of extrude 2 is what it selects, but that's me just hitting non-motor intake. And then what I'll do is I'm going to hide that part and unhide the intake plate motor. And I'll select that one. So now we can see under the faces here, we have face of extrude 1 and face of extrude 2. And extrude 1 is adding our intake plate motor part, and our extrude 2 is what added our non-motor intake. And for the radius, I'm just going to do 1/4 of an inch. And what this does is it rounds off all these edges for us. And if we wanted to, we could go over here, hit exclude, and exclude that. But I want to fill it all the edges. And I'll hit select. For an example like our motor mounting, if we wanted to change which one had the motor, we could change. This doesn't really change much since they're basically the same part, but we would just deselect that for the merge scope and hit this to change what it's merging with. And I'm just going to hit X to cancel those changes. Does that answer your question, Wildcard?
Yeah, thanks. Thank you.
Yep. So, is everyone here to this point?
No.
Okay. Do we all have the fillet all edges tool?
Where you lost me was in the roll back to the extrude 2.
All right.
Okay, I was not able to successfully do that in time. So what do we need to do?
That was a fix for a problem those 4 were experiencing. You should be fine.
So I have extrude 1 and extrude 2 motor mounting, and then the plate motor, I don't have a second intake plate.
You only have 1 part in the list?
You have
Yeah. Okay. So
You just wanted to fill it. It's too much.
that modification was some of the students had extrude 2 deleted, and it was enough students where it made sense to show it up here on the TV. So do you have one part that looks like this with these holes? So both of them look like this. I'm gonna. Oh, that's because they're overlapping. So if we easily start up here, you can see it at the leaves are solid lines, not more sketches. That shows that our intake has no holes. So if we hover over the non-over intake, and we put the eyes behind
It's a part of studio, so essentially
you have that pipe.
it's not just one object.
So we put that in.
And because it's cloudy, none of these actually exist as a solid map. So each of these parts exists as a single part in a studio. And a studio is just the environment that they exist in. What if you move it free?
Oh, they are not.
Yeah, I just transformed it up again, but I think it's two parts.
Wait, actually, that was all. There's no way that was all we did. And I was still like,
Okay. Now you found that feature.
Ooh, and you want to
And I'll show you.
you can drag these into any
So with what? All right. What do we need? Oh,
It's the fact that they don't use the file. Because it's
Okay.
file-based,
So,
you have to say
go to your
files.
insert.
In a file, you actually have to
Okay. So
You can
the
hit
reason that
export
happens
field.
is our ATM our doesn't have any slash. So I
Oh,
want
you're
this.
talking about the video, right, what's that?
And select this center. Just hit it once. It's just makes
oh, wait.
Then hit left. And then hit X or the check to confirm.
There's no way.
Oh.
And now
Everything that I
for your fillet all edges, split the face of that.
you can make a new part studio for
Like
every
how far-
part.
He just led me so bad.
And then you just essentially get the same studio.
Go to your insert.
I do it under this.
Yeah.
Yes.
Like double click on it.
Yeah, so if you, yeah, it's
Change
essentially
it,
a
yeah.
project
Here.
file.
To point
And if you want to get something from outside of this file, you have to use derive to extract it from another part studio. Outside of it.
Enter.
Wow.
I ran the sheet.
Your extrude 1 looks involved.
You have an extra right here, so you should just.
Yeah, it is.
No, it isn't. Go to your extrude, Jim.
Okay, so you kill that, and grab the face. And
Deselect. Oh, deselect
So
face
then
of
you grab
extrude
both,
1.
and then that should fill it all.
Hit sketch 1.
Oh, no,
like
one
that.
face,
Go
you
to
go
your
here
extrude
too,
2.
and because you have two plates.
Extrude 2, not 1. So
I
then
moved them
click
apart
on it.
because I don't like how that looks. I don't like how that renders. That's my personal.
Okay. Hide your intake plate. Hit sketch 1. Go to here. Okay. And then this is circle. Hit the check. And then move your roll back bar. Yep.
Drag motor around the
And your other part.
I like pay for a solid host license.
Yeah, well, I realized that I accidentally.
I like okay, inventor is set up in a way where it does not value visual performance. It values representation of the point.
Okay.
Which means that if the line is at an angle from vertical or horizontal, it will be staggered like you drew it in a pencil. I like that shape because
Are we all good and all discussed to fill it all edges? Are you all good?
it allows me to go.
Okay. For those of you who have fill it all edges, was a hand raised?
Yeah. Could you go through the steps of adding another part to your part studio and tying that to all the features but one, maybe?
Yeah. For those of you at home, don't follow this right now. This is for wildcard. So what I think this is what you mean. I'm going to move the rollback bar to a sketch one. So right now, these all are hidden, and it's acting like they don't exist within the cloud.
Mhm.
So I'm going to extrude. I'm going to use the extrude tool. I'm going to extrude this plate with a depth of 1/8 of an inch, and I'll have it as a new solid part. I'll hit check to confirm this, and then to make our second part here, what I did is I hide this part one, and I extrude a second time. So now it automatically does solid and new instead of trying to add it to our previous one. So I'll hit the face of the sketch to extrude it. And I want to fill in this circle. And this also has a depth of 1/8 of an inch. I hear a lot of clicking here. This is for someone on the Google Meet. So you guys don't need to be following along with us unless you just want extra practice. So then I have part one hidden here. So I'm going to, for this motor mounting tool, I'll select the origin of this sketch that I want, versa planetary, overriding the size to 1.125, 2 holes. The angle will be 45, and I'm going to have the angle reference be this bottom line here.
Sure.
And then the merge scope, I can just select this part 2, and that means that this motor mounting
Only applies to that one.
only applies to 2. And then I can go here. I can fill it all edges. And for face, right now we only have the faces of part 2 visible. So I'll just hit part 2. It's showing me that it's selecting from the face of extrude 4. And then I'll hide this part 2 so we can show part 1 and select the other one. And so then we're selecting face of extrude 3. And we're filleting both plates. And so if I select this, we can see part 1 has these fillets and no motor hole like we want. For the extrude, I would have wanted this selected. And then if I swap here, it shows that we have this motor mounting hole only on the part 2, and it also has all edges filleted.
Okay. And now, what would happen if you unrolled or rolled back that bar? Was that possible, or?
If I rolled back that bar right now, it would remake the same 2 parts. So I'm
Right.
going to delete these.
Okay. Yep. Makes
But
sense.
if I roll back this bar, all my features come back.
And renames and everything. Sure. Great. Thank you.
Yep. Does that clarify it for you?
Yep.
All right. For us here, are we to this point? Where, if I lost any of you, where did I lose you?
Wait, so are those two holes supposed to be C2?
What do you mean see-through?
Because they have the non-motor plate, so for your part two, they have that one not visible, the other one visible. To make that top visible. Yeah, and they don't know where that not visible. Yeah, that's on something.
All right. So is everyone to this point? Do we all have all the edges filleted? Okay. Are you able to catch yourself back up, Sam? Or okay. So now with our work in progress intake here, there might be some errors just because of the way these parts were made. So I'm just going to delete both of our made parts, and you guys can follow along with this too. And we'll only have this motor here. This is what we made those mounting holes for. You can see it has the 2 diagonal holes here with this rectangular shape. So do we all have this work in progress intake assembly with only this motor? I deleted under instances here. I deleted everything that wasn't this Neo 550 Versa Planetary. And I deleted any mate features that were there.
Deleted everything below the top 2 items.
Yep, so all that we should see here is this work in progress intake. That's the name of this assembly. The origin, which is this center point here. And we have the Neo 550 motor here. And we have no mate features that are under this dropdown. Yeah.
Dysfunctional pieces of the rest of the intake.
Yeah. Yep. Delete everything on this Neo 550. Your Neo 550 won't be the work. If you check work in progress,
Those are all mate
it's
features.
going to delete everything. So click
Yes, and then delete those 2 plates.
you want to be importing on the left, which would be that. Yep. Great.
Right, it's like delete.
Yep.
So now I have that, and that's what you wanted me to have.
Yep.
What's that dot doing up there?
That's the origin. So we can put stuff at the origin.
Okay, where did this Neo come from?
I imported it
From.
a step file.
Okay, I was wondering because
That was on the
usually
back
it doesn't
website.
turn, usually it doesn't turn all that multicolored if you import it from MK.
Yeah.
I don't know where.
I can help if anyone else has those issues.
I had to.
Which is your? Okay, you're good.
So.
I had to.
What's up with you?
So I had to redo because I have one of these of the
Yeah.
non-construction supply, so I had to delete it and replace it.
Yeah.
So now my schedule is.
Okay, so that extrude one switch. So we can check on that.
Really?
Yeah, what is your extrude two? That one's right.
Okay.
What is your motor? Oh wait. No, it isn't. So go to your extrude.
I assume what's going on.
So you add the same. So right now you're adding to the partition already.
We did
And that starts on a separate part. And so then we can check.
Okay.
And that should be right.
Well, we have a
Alright.
second me over there, but.
Go to your assemblies, user. The work in progress
I
intake.
think we're already using some HDMI hack together.
Okay, you guys did it.
Okay.
Yes.
Kyle, you know what's gonna delete this stuff in the assembly?
I don't think you can laptop has an HDMI port or HDMI port, so plus you can.
It only has USB-Cs.
Is there a second HDMI output on that block, or is that all it does?
There's an SD, a TF, USB 3.0, USB 3.0, and USB 3.0.
Okay, one and one HDMI.
Alright.
Does the TV?
Yes. It's okay. What are you wanting right now?
Yeah, face it in two different
All right.
directions. So the entire
So for some of the fun stuff, we have our assembly ready. So the first thing we're going to do is we're going to grab our two intake plates. So if we go to insert, it might show it in a different order than what you're seeing from me. So if you don't see intake parts in this dropdown, we can look up intake and it'll show us two different things that have an intake in their name. We're looking at this intake parts one, and we want to click in one instance of either of these two parts. So then it'll show inserted two. We can left click to just confirm any random location for these.
How did you get to that box? How did you get to where you're searching?
Yep. To add instances of any part, we can hit the insert button here at the top. It gives you three different options: current document, other documents, standard content. For what we're doing right now, we're inserting from a part studio. And, oh, it automatically grabbed it when I hit part studio. Or I don't know what those are. But we're going to import these two parts. The two intake parts. And we'll just click to confirm that. I'm going to delete these two that automatically just joined in. So, do we all have these intake parts here? Do we have our two intake pieces in our assembly with a Neo just floating in space? All right. Once we did that, right now, all this stuff is floating in space, and I want to fix it to a point. And it gives us this origin point. So I'm going to use a fastened mate. So that's here at the top. You can also hit M. So it'll give you this little drop down similar to what we've seen before. And it asks for two mate connectors. So if we start hovering over these parts, we're going to see all these points start to highlight. And these are different points that we can select and have two things be joined together from. And so what I'm going to do, I'm going to grab the back of this plate. This is the motor, the one that has the motor mount, the one with more holes. I'm going to grab the top right of it. So where there's more on the bottom here. I'm going to grab this top right one, and I want to make sure it's grabbing the center of this circle that's facing me. And sometimes you'll click and it won't confirm. You want to make sure where it says mate connectors here, that it does get selected. Then you're going to go to your origin point here, and we can just click on it. And what it'll do is it'll have these 2 points be joined together. And then it gives us 2 different options for a check mark here. We can either hit this one, and as I see here, it says commit current mate and start a new mate, or we can just hit up here, and that'll take us out of this menu. I want to start a new mate right away, so I'm going to hit this second check mark. And what I'm going to do is I'm going to grab this same point here on our plate that has a motor mount, and I'm going to grab the adjacent one on our second plate. And so we can see right now that what that does is it's going to stack these plates right on top of each other. And then we can go below these mate connectors in the top left, and we can click this offset button. And so there's different options for how you can offset parts in a mate, in a fasten mate. But what we're going to do is we're just going to look at this. It says the Z-axis is what's pointing out. And so we're going to change this Z number to 18. And what that'll do is it has these points negative 18. And I'll explain why negative 18 in just a second. But we want this Z to be negative 18. And I'll hit select.
Which side you joined. So are you joining the inside to inside and then minus 18, so there's 18 between them, or is it 18 offset from the same face of each one?
It's undoing my stuff. What I did is the first two mates I selected were the inside of both. So when we have these in our assembly, we're going to have the two plates on either side, right? So I just grabbed the inside of one and the inside of the other. And so what that'll do is it just joins them so they're stacked on top of each other. And then I added negative 18 so that there's 18 inches between the parallel faces. And it undid some of my work. I don't know if any of you are running into that, but... And then we can confirm that there's 18 inches between these parallel points by selecting these two inside faces, and it looks like there isn't. And this is why I hit negative 18. Because when I did 18, it's had them go into each other. So we lost 1/8 from one plate and 1/8 from the other. So by switching that to negative 18, that will get it. Gabriel, why are you in my document and not yours?
Whoopsies.
I think that's why it's undoing my changes. I think Gabriel's been undoing it. So, if we look at these parallel faces with the negative 18 for the z-axis offset, we can see 18 inches of parallel distance. Are we all here? What do you mean you don't know?
I don't know. I lost it.
Haven't you been editing yours this entire time?
No, everything just. Oh wait. Because I think
Wait, when did I do it?
Good at kids.
Why am I back in intake class?
Oh right, 5 to 5.
I'm not back in intake class.
What time is it?
7:00.
You were supposed to put your name. You're gonna make a new copy tomorrow. You're with your date.
I'm with your date.
You're with your date.
Oh, yo.
Okay. Oh, Ashton. Yep.
Bro, you're so.
So for some reason.
Oh, that's because the mates that you must have selected aren't the center of the tree. So, that's with me. Not that one. That's the one that lost it. So your second best. And yeah, so it looks like on this so the non-board of that case, and hit the center of that circle.
We're offsetting. We're both like 18 inches from the great plate, right?
Yeah, no. Unselect that again.
I was wondering why you
Unselect it. Unselect it. So we want the center of the outside. So we're gonna hover over the edge.
What did you do?
Like that. We want to see the CF. And we're going to do select the same on the bottom. Do you have a question?
Had a search
Check the share left is the name. You're going to do that? Now we want to check the parallel distance. Select the two faces of the face.
Is it that or not that?
But here's
I'm researching a team that used carbon fiber boat for their.
just negative 18. That's the way your rates were selected. You want to just do 18.
Yeah.
Double click it to.
So they found this obscure looking company
You're good.
that makes carbon fiber boats to roll their boats. And buy this like orange extender roll. And you spin it away and extend it out and it creates a really rigid like tube structure. And so I think some teams used it last year, this team's using it for extension this time. I think grab crumble potentially easier because now I can put it too, but
Everyone else did it fine.
you might be able to even fit it on that bar seal. You know, apply to like
Okay.
last minute winch thing. Like I did.
We're an hour into it, and how many of you need help to get to this point? Okay. If we get to a point where a lot of you need help, we're going to take a break and I'll go around and help everyone. But what we can do is under this intake folder, we have a folder called intake COTS, right? And so if we enter that, we can see this is where our motor is coming from. It was an import that I'd put in, and it shows the different parts that make up it. But that's not what we care about. We're going to go to intake COTS. Okay, it should be an empty part studio. Do all of you have that? For intake COTS. There's a chance it's not empty. Okay. So this is where we're going to import our MKCAD parts. The reason we're importing it into the part studio instead of the assembly is so that we can change the tessellation quality ourselves, so that we can make it load better. So it's gonna look like a jumble of parts here, and I have the list in front of me, so I know what we need to grab. So first, under bearing, it's in my favorites. Let me see. We're looking for this 0.5 inch hex ID.
He opened the brand, or no, he,
It was a part studio that should exist in yours. It's under the intake folder, and it's intake COTS folder, and then it's the last part studio within there. Is everyone in this empty part studio? I'm gonna wait till I see a thumbs up from all of you.
It's an intake folder, intake COTS.
Yep. So if we look on the folder or this bottom directory, we can see that we have one folder. This is our top-down configurable. This is where we're working out of. Then we have an intake folder. Then we entered an intake COTS folder. So it's a copy, so it's not mine.
Okay, so this is mine, okay.
Okay. You're okay. He just made its own. It should exist already. Okay. Everyone here?
he clicks that, MKCAD.
Okay. We all have MKCAD downloaded, right? Just a double check. The thing we got on the first day. So if we look on the right of our screen, we see these 4 boxes. Do we see the one that's a blue square with the letter M and the letter K? Here on the side, right where my mouse is. You didn't install it?
Mine wasn't there yesterday, now it's here today. So I still
I don't know how to fix it. Ryan, did you fix the problem John was having yesterday?
no.
I gave him, I got the MKCAD to show up on assembly. Yeah, I don't know why it didn't show up in part studios.
Okay.
But I guess that's.
What is Suhaib struggling with right now? Does Suhaib have it? Are you good? You're installing MKCAD for him? Okay. If you're just installing MKCAD and it doesn't show up for you right away, that's been happening for a few people. So you might have to look off of someone else's document and just wait a couple days. That's what one of our mentors had to do. But yeah, a day. But for those of us with MKCAD, we can go to MKCAD driver, and there's all these drop downs of things we can add. So we'll start with the gears. And since this is a part studio, even if we need multiple of one part, we only put in one because we can just, in our assembly, we can call more instances of the same object. So what that'll look like is just clicking the same part multiple times. So for right now, I'm going to type in the search bar of MKCAD right here. I'm going to type in 20 DP. That'll only show me gears right now. And then I'll put in 36. It disappeared. Let's see. We can also just scroll down here. They're all listed based off their teeth count. So we're wanting to find a 36 tooth DP, 20 DP aluminum half-inch hex bore gear. It'll be this one. So for those of you who want to use the search bar, you type in 36T spacebar 20 DP spacebar aluminum spacebar 1/2 quotation mark, and then it should show up. So are we all able to see this part in MKCAD? Suhaib, do you have MKCAD? Are you able to find this part? Yep, 1/2 inch hex bore. And it's aluminum, not steel. If we look at the part number, we can see it's 2173214. The part number is what's in parentheses at the end. And so if we click on it, we can see it imported a gear into this part studio for us. And it says it's derived, and this shows the feature that added it. So if we deleted this, it would delete our gear. So do we all have this one gear? For all of us with MKCAD.
Bro, try like clicking out of it and then clicking back in. That's what I did. And it's still just flashed up.
Oh,
That's weird.
wait. That's all you can do. Sometimes it won't pop up immediately. Okay. You have it. You have it. You have it. You go back to your document. Hit reload. We'll see if it shows up for you. It might not show up for you. If it's
No.
authorized. That's how you get that back. What? Then look up 36T. Yep.
Yeah, so.
Once we have this, we're going to do a very similar thing for the rest of it. Now that we know how these are named in here, I'm going to type it instead of scrolling through. This next one is going to be 20T, 20DP, and it'll show it hidden right now. I don't know why it shows all of this one, only some of it applies. And we're going to look for this 20T, 20DP aluminum half-inch hex bore. And we'll put that in the part studio as well. And it'll just be on top of the other one. That's fine for right now. If it upsets you, you're able to move it. It's just not a big deal for what we're doing. The next thing we're going to add is 42T. Hey, it pops up. It's this first one here. 42T, 20DP, aluminum, half-inch hex bore gear. We'll click that one to add it. And while we do have 4 gears, we have the 36 repeated. So we only need one of them in the part studio. Yep, 36 tooth, a 20 tooth, and a 42 tooth. All of them are made out of aluminum, and all of them have a half-inch hex bore. And then, the reason we have these in a part studio is so we can go to the side here. We see this parts list. It says parts, parentheses 3. And we're actually able to right-click on it. The fourth option from the top, we have edit appearance. And so we can see it says one fine part down here in the bottom. We don't want that. These gears especially add a lot of load time and a lot of primitives. If we look at the performance, these have 51,000 primitives, these 3 gears. If we remember back to yesterday on the presentation, I showed that we were able to get a full drive base to have 180,000. So we can do better than this 50,000 for 3 gears. So we're just going to change the tessellation quality to coarse on all of these by right-clicking the part, hitting edit appearance, and hitting coarse. And then we hit the check to confirm it. We can, if you don't like that, on the side here, there's the appearance panel. And it makes it so there's only 1 or 2 options you can choose to click on. And so that could make it a little faster. It's just whatever is faster for you. But it is 1 at a time. At least That's the fastest way I know how to do it.
I was able to select all of them and then so edit appearance, right click once they were all selected.
Huh.
And then from there I selected the course.
Nice. I didn't know you could do that. John Radke brings up the point that we can select all the parts within our part studio, edit appearance for all 3, and select course for all of them at the same time.
Might be handy when you're doing complex parts and you have a lot of parts.
Yep. So, a 36, a 20, and a 42 half-inch hex bore. The next part we're going to add into here is the bearing that we're going to be using for this intake. So we can type in 0.5, 1 parenthesis, and then it's hex ID, and what is the difference between these? Oh, I found it. We want this 0.5 hex ID 1.125 OD flange bearing, and not the 0.375. We use bearings, or at least we did a lot last year, so I have it favorited so that I can grab it easier. But that's not something you have to do. I'll go over not overlapping it. Yep, you just select the heart to favorite it. After we import all these parts, we can take a short break. So the next thing we're going to add, this one has some configuration with it. So we're going to look up 1/2, so 1/2, not parenthesis, quotation mark, and under extrusions and shafts, the only 2 options are this churro and this half-inch hex shaft configurable. I also have this one favorited because we used it a lot. So if we left click on this one, it gives us a lot more options than all the others. So for the effective length of this part, what we're going to do is we're going to do 18.5. The profile is half-inch hex. For the S1 retention, so the way it's going to stay still on one side, what we're going to do is a bolt and washer, and we'll do the same for the other side. So if we click on this, it's just a drop down. For the S1 hardware, we're going to use the option it automatically gives us, include and merge everything. If we did don't include, it's going to, our hex shaft is going to have the geometry it would have if we had this bolt and washer. So it'll have little holes in the edge of it, but it wouldn't have the bolt or washer. The include but don't merge would have each washer and screw as a separate part. But the include and merge makes it so our shaft and our bolt and washer, it's all one part. And that's why we include and merge all of it.
You made this 18.5 inches long.
Yeah, because it has to extend past.
But it's 18 inches between the 2 plates.
That's on the inside face. It then has to go past some bearings.
And that's the inside of the bearings, which the bearings are each 1/4 of an inch thick. And actually,
It's based off what is actually on the robot. There is purpose to that measurement. The next thing we're going to add is our intake wheels. So we'll do 2 quotation mark OD, and then we'll go to wheels, as in the letters O and D. It's showing me more options than I like, so I'm going to do 1 divided by 2, and then another quotation mark, and then I'll hit wheels. It's still showing me a lot. So what we're looking for, let's see, this 2-inch outer diameter, half-inch hex bore compliant wheel, and then it shows AM3462. And it'll be green on the side here. So when we insert it, we're able to change the configuration, and we did 40A orange. For those different numbers, it just changes the hardness of the wheel. And 40A is both in the middle and our team color. The next thing we're going to add is a locking collar so that everything can stay in place on this shaft. So we'll do 1 divided by 2. I have it written down as IN. And under spacer hub, it's the first one here. It's the only gray one. We'll put that in as well. And then
I need to catch up, sorry. I'm still struggling with the export.
yeah, we're going to take a break after this. I'll get you caught up. So then we can hold shift, select this first 36 tooth gear, or don't hold shift before, select that, then hold shift, and select this bottom part. So that'll select all of them. We're going to right click, edit appearance for 8 parts. Tessellation quality, we're going to change not to auto, but to coarse. And so that's 24,000 primitives instead of 151,000. Okay. We'll be back in roughly 10 minutes. We're going to get everyone caught up, and then we'll resume by adding it all to the assembly. See you in the next part.